Resistivity is a metric or property of all matter. And it doesn't matter whether it's conductors, insulators, semiconductors, they all have a certain amount of resistivity. And it's a property of all matter to oppose the flow of current. There is no such thing as a perfect conductor. So the resistance is found by this value rho times the length of the resistor or the material divided by its cross-sectional area. And so rho is called resistivity, and its units are ohms meters. So resistance increases as the length increases, and resistance decreases as the cross-sectional area increases. Now it turns out that resistivity is also dependent upon temperature. So the resistivity at some temperature T is equal to resistivity at a specific temperature, and that's taken at, I believe it's 0 degrees Celsius, and then 1 plus alpha, this is your temperature change coefficient, T minus T naught. So the warmer a material gets, the higher the resistivity. Very few materials show a negative alpha. It's not really known, there's a few semiconductors typically have a negative alpha. And that's due to the nature of the material. There's some specific phenomena in the quantum level that causes that to happen. But for most materials, alpha is a positive number. Now there's a table of resistivity in the notes and in the book, and there's two that I want to talk about. We have copper, and its resistivity is 1.68 times 10 to the minus 8th ohms meters. And aluminum, which is 2.65 times 10 to the minus 8th ohms meters. So back in the 70s, 1970s, prices of copper went up. And aluminum was new on the scene, and so the price of aluminum went down. And so at that point, contractors or people building houses, contractors decided that aluminum wire was cheaper and the resistivity resistivity was close to copper. So they started building houses with aluminum wiring. And the idea is pretty sound. The resistivity is not that much different. Uh, and you would think that everything would be well. And all of a sudden, the number of house fires due to wiring increased as the number of homes that had aluminum wiring increased. So what was the problem? The resistivity is not that much different. It shouldn't have been that big of a problem. It was kind of baffling. But here's what you have to think about when you're deciding to use a new material. Let's say I have a piece of copper wire and I need to bend the wire. So I'm going to bend it. What happens on a molecular level with copper? Well, copper is fairly malleable. I believe that's how you spell that. Meaning that you can bend it and it won't stress, won't cause a problem in doing that. It won't do any kind of fracturing. But aluminum, on the other hand, if you bend aluminum, it will create fractures. These little micro fractures. And I'm really making these big, but just to make a point. And so now, as the current flows through, don't forget your resistance formula. Resistance is equal to resistivity times length divided by cross-sectional area. You're decreasing the cross-sectional area, meaning that the resistance is increasing, and when you increase the resistance, increased resistance produces more heat. So you've basically just put a toaster oven behind your wall. And if you have wood studs, you've just now put a toaster oven right next to the wood in your house. And so that's why the number of house fires started to increase because of aluminum wiring. So now aluminum wiring is not allowed in houses. It's been ripped out because of the fact that you get these fractures. And if you want to see how that how bad it is. Take a piece of copper wire and bend it. You can bend it a number of times and it won't break. Take an aluminum can and bend it, and you'll see it creases. It creates that crease, and it's that crease that has those fractures in it. So there's an engineering situation where you really have to think about the materials that you're using. You might think, well, I can get away with resistivity, but you have to think about all of the issues. What does the material do under stress? Because that may be the difference between success and failure.